Am I audible? Please just confirm whether I'm audible or not. And the screen is visible or not. Both, please. Just you can write in the chat box also, or you can use your mic also. So I'm audible. Please just confirm. Anyone? So then we'll proceed for the questions. You can write in the chat box also. Okay. Okay. Thank you, Deep. So we'll start within 2 minutes, maybe. Okay, Shreya, thank you. So maybe other participant will join. So I'm waiting 2 minutes more, then I'll start. Today we are going to solve assignment number 8, week 8, and similar as the previous the discussions, we have the three assignments from your week, from your 25 year, 24 and 23. So we'll solve all questions around 35 questions. So please wait 2 minutes more. Maybe other participant will join. They will start. Or let me just ask to all of you whether this session, whatever I am here conducting, these are helping you for the assignment or not. Please you can write in the chat box yes or not, yes or no. If helping, then please you can write yes, otherwise okay, thank you. So I think the more or less question are similar from these three previous years. So that's why you are able to solve all question, or also I am discussing here little bit concepts also. Or you can follow my, actually I have uh, taken lot of, okay, thank you Deep. So actually I have taken lot of live sessions from the fluid mechanics and hydraulic engineering both. Maybe I think this time I am taking the sixth or seventh time this fluid mechanics or hydraulic engineering combinedly. So when you will go the YouTube channel, uh, then you will find the previous lecture also. So in the first lecture, that is I think the fluid mechanics 2023, I have teach concepts also. After that I have teach only the, because I have lot of questions, so that's why I'm more focusing on the question, or the main aim of this session is to solve lot of question and concepts. Anyway, sir has discussed in the class, that is online class, NPTEL, the lot of concepts. So these session designed for mainly the talking about the problem, that is numerical problem, objective problem, and some concept. But initially I used to, that time I was I think in 2023, so I have teach the concepts also, so please you go through. If anyone have any doubt, you can ask in the class. Okay, so now let us start. So here question is, first question, uh, for a fully developed pipe flow, how does the pressure vary with the length of pipe, whether it is linearly, parabolic, exponential, constant, for a fully developed pipe flow. So you have to know first what is fully developed pipe flow. then you can understand. Okay, so please just try to think and just write your answer. Which option should be correct? Okay, Deep is stating linearly. Okay, fine. Other student, please. Other student, please. Just think and try to write your answer. Deep is telling option A, linearly. Okay, so let me just show you the answer. We are talking about here the fully developed flow. So what is meaning? Let me just explain you. So suppose this is a pipe. So assume the water is entering from here. So now once water will enter, due to the wall effect, what will happen? The boundary layer will be formed like that. The boundary layer will be formed like that. The boundary layer will be formed like that. After that, the bound, because as you moving in the downstream, what is happening? Wall length increasing. As wall length increasing, your boundary layer become bigger and bigger. In the wider, I'm telling, wider and wider. After some time, it will be from both wall, it will be touch here. So what will happen? Initially, if you will see the velocity distribution, how the velocity distribution up to here, parabolic. If it is linear flow, then here is constant, then parabolic. But you know, in the linear, your fluid varies like parabolic. But this parabolic graph, after this, here if you will draw this graph, this is like that, then little bit straight, then your parabolic. But here it is this the both this let us suppose this one is first and this one is the second. So both boundary or both boundary layer here, the gap between the boundary line is negligible. So what will happen after that? You will get complete parabolic velocity distribution. We are talking about velocity distribution. Here question is talking about pressure. So don't be confused. I'm just telling you here the concept behind the your fully developed. So from here to here, this is your fully developed length, fully developed length. So remember please. So this will vary. We have formula also. And for laminar flow, what will be the length of fully developed flow? Fully developed length for laminar case as well as for turbulent case. Both we have. So you just please follow the standard book or you can just search on Google, you will find out. In case of pipe flow, or you need to search. Okay, so the answer for this question is linear. Always remember the pressure varies linear and your velocity varies. Your pressure linear and your velocity varies parabolic. Remember please. In case parabolic when the flow is laminar. Always remember. So what is written here in the detailed solution? In a zero acceleration, fully developed flow in a pipe, the pressure gradually decreases linearly along the length of the pipe. Hence, pressure variation is said to be linear. Always remember, please, your flow possible from high pressure to low pressure. Always flow in the direction of high pressure to low pressure pipe flow. So here is, if someone asks you this is point 1 and this is point 2, so where will be, and flow is moving from here to here, from 1 to 2. So pressure will be more, pressure at 1 will be more at pressure 2. So this is some basic understanding, always remember. That will help you for when you will solve the numericals based on this, especially when the Bernoulli's numerical when you solve. Okay, so now come on the question number 2. The Darcy friction factor for linear flow is a consequences of Pauli's law, Bernoulli's law, Euler law, Newton's law. So here we are talking about Darcy's friction factor for laminar flow is a correspondence of which option? Very simple question, but need to some understanding about the Darcy's friction factor, how it derived and all. So now please you just try to solve. Very easy question. Hope you all know the formula of the Darcy's friction factor. So everyone please just try to think and try to write your answer in the chat box. Anyone please just try to write. Anyone please? Okay, so let me just explain you very in the simple way. So here you have, the question is asking about in case of laminar flow, your Darcy's friction factor. Darcy's friction factor. So what is it? So F, we only denoted with the F. So now it consequences of your, whether it is Pauli's, Bernoulli's, Euler's or the Newton's. So it is your Pauli's law. Remember please. The consequences of Pauli's law. So here detailed solution, let me just read. The the Hazen-Pauli equation can be derived. Let me just little bit shorter. Yes. So Hazen-Pauli equation can be derived from the Navier-Stokes equation. Always remember please. Navier-Stokes equation, I'll come again. The linear flow through a pipe of uniform circular, assume the circular cross section, is known as Hazen-Pauli flow. Means what is Hazen-Pauli flow? The laminar flow through a pipe of uniform cross section, or cross section should be circular. The Darcy's friction factor for laminar flow is a consequences of Pauli's flow. One thing is very interested. when we will going to calculate this factor f in case of laminar flow, it follow 64 by re. Always remember. Now in case of turbulent, this is your laminar. In case of turbulent flow, your friction factor you need to calculate using Moody's chart. Remember please, using the Moody's chart. Or one equation is there, Moody's equation you can say, or I think some equation was developed by another other scientist, and the Moody's try to write these equation in the form of this graph. So here little bit I have confused. So you please go through the textbook. You will find out. The equation is something like that. 1 by root f is equal to something something. So remember please. So this friction factor you need to calculate differently in case of laminar flow and the turbulent flow. Generally in the uh, examination, like gate type of examination, this equation you will I think provided. Okay, so remember these things. Now we'll move on the next question, number 3. So shear stress distribution in the middle of pipe follow is, okay, shear stress distribution in the middle of a pipe follow maximum, minimum, same throughout the pipe, all of these. Okay. Okay, shear stress distribution in the middle of a pipe flow is maximum, minimum, same throughout the pipe, or all of this. Okay, in the middle. Okay, question is talking about. I was a bit confused, but now I understand. This is the your pipe, and in the middle you need to calculate whether your maximum, minimum, same throughout the pipe, or all of these at this location. If we talk about, this is your from top to, that is the diameter of the pipe, so we are discussing about at the middle. So now I need answer from all sides. So this question I think was asked in the gate also, the similar question, not in the middle, throughout the, I think question was about in the gate, the distribution of your shear stress. Now please just try to write your answer in the chat box. Okay, minimum, Deep is telling minimum, option B, because velocity gradient is 0 at middle of the pipe. Okay, other student please also, you can, if you want to write your answer, you can write within 1 minute. So I'm waiting 1 minute more. Okay, so let me just explain you. Yes, Deep is correct. So at the your here the very minimum shear stress at the center. Shear stress varies like that. At the wall, shear stress is very high. Here, shear stress is very high, but at the center it is, you can say, minimum or zero. Okay, negligible. So detailed solution, shear stress distribution in the middle of the pipe flow is minimum while velocity distribution is maximum at the middle. Means your velocity distribution maximum means, as you know, the parabolic flow. So it is maximum like that. Maximum at the middle. So this is. Now we'll move on the next one. Question number 4. So in laminar flow through a circular pipe of 20 centimeter diameter, here you can see the flow velocity at a radial distance of 5 centimeter from the pipe axis is 0.75 meter per second. Radial distance 5 centimeter. Your diameter is 20, remember, 20 centimeter, or once you explode then I'll explain. And what is the maximum flow velocity in the section? 1, option A 1.25, option B 1.0, option C 0.50, and option D 0.25. So what will be the maximum one? Yes, please. So very easy question. Just please try to calculate. Anyone please just try to calculate and try to write your answer in the chat box. You have another 2 minutes.
Hose is telling option B. Okay.
Okay, so let me just explain you. So here your question is you have a laminar flow through a circular pipe. Okay, this is your circular pipe. Now the diameter of the circular pipe is 20 centimeter. The flow velocity at a radial distance means real distance 5 centimeter. So here from here to here you have 10 centimeter, and similarly in the 10 centimeter this side. Now 5 centimeter here. Your velocity have how much? 0.75. Means when you will draw at that level, the vector size is 0.75 meter per second. This is your maximum one. Now, what is the maximum velocity? You need to calculate this maximum one. So always remember this, if it is 0.75, your maximum will be greater than 0.75. So these two options you can neglect. So similarly, if let us suppose this your option A and option B was less than 0.75, so you can neglect and you can go directly without solving the answer. But here you have the more than 0.75 two options, so we need to calculate. So like that you can also think such type of question. Okay, so here this is the relation between your velocity at a particular location and the maximum in case of the pipe flow. Remember please, pipe laminar flow. Now, so u is equal to u max. So u is equal to u max, and this is nothing but your r square is nothing but your 5 centimeter divided by your maximum at 10 centimeter. This is also a square. So centimeter will be cancelled out. So that's why here I am putting. Okay, so now your this is 0.75 and this is your u max, and after the calculation you will get 5 by 25 by 100, and finally you will get maximum is equal to 1 meter per second. So remember please how you will solve. So always remember this relationship. The u is equal to u max, the 1 minus r square by capital R square. Now we'll move on the next one. Next question is question number 5. Again, so here you have formula based question. According to Darcy's formula, the loss of head due to friction in the pipe is loss of head due to friction in the pipe is where F is Darcy's coefficient, 1 length of the pipe, one not n, one here is a L, this is your L is the length of pipe, V is velocity of liquid in pipe, and D diameter of the pipe. So now you have to choose option. 4 option here. Option A, FLV square by 2ZD, FLV square by GD, 3FLV square by 2ZD, 4FLV square by 2ZD. Remember please, your this F is here Darcy's coefficient. Darcy's coefficient. Sometimes these F may be your frictional coefficient. So if these here you no need here you need some information how this Darcy's coefficient or the friction coefficient are related. So but in the question is given your the Darcy's coefficient. So based on thing the question is totally depend on these two things. So please just try to calculate and try to think actually. Here is no calculation and you can write your answer in the chat box. Very easy. Okay. So Deep is telling, Ghost was telling B. Yes, for question number 4, B was correct. Now the Deep is telling option D. Okay. Let us see whether D option or other student. Please also try to write your answer in the chat box. You have another 1 minute, or you can, I'll give you 2 minutes also. So within 1 minute, please just try to write your answer. Then I'll explain. Okay, Shreya is also telling option D. Okay, fine. Okay, so let me just explain you. So here you have this, the question is asking about head loss, HF, whether it is your 4F, the actual formula FLV square by 2ZD or 4FLV square by 2ZD depends on these two things, whether you are using the friction coefficient or the Darcy's coefficient. So here, remember please, according to Darcy's formula, the head loss of the head due to friction in the pipe is given by HL is equal to 4FLV square by 2ZD. So Yes, you both are correct here. Both are telling option D, I think. Yes, 5 is D. Sorry. Actually, I think this question, I think we have also discussed in the previous one in the week number 5, or yes, week number 5, I think we have discussed the similar things, the head loss and all. Okay. So now we'll move on the next one. Question number 6. For laminar flow through a long pipe, the pressure drop per unit length increases. Option A, in linear proportion to the cross-sectional area, in proportion to the diameter of the pipe, in inverse proportion to the cross-sectional area, in inverse proportional to square of the cross-sectional area. So here you have four options. So please just try to write your answer in the chat box. For question number 6. So anyone please? Okay, so Deep is telling C option. In inverse proportional to the cross-sectional area. Okay. Okay. So before going to this, so in the first question, in the previous question, question number 5, I want to just here explain you. So this is your F is Darcy's coefficient friction. Remember, please, always remember. And when we will consider this friction factor, the friction factor, then your friction factor, let us FF. So your FF is equal to 4F. So Darcy's coefficient, Darcy's friction coefficient, you can say. So here I was talking about not frictional coefficient, the frictional factor. These initially these the both was same, but now you can just think about whatever I have just explained. Okay, so now we'll move on this. If the in the question was given the friction factor, so you will go with the first one, FLV square by 2ZD. Always remember your friction factor will be more, your friction factor will be more than your friction coefficient, or Darcy's friction coefficient or friction coefficient, both are same. Okay, so now we'll move. Okay, so here you are telling option. Let me just go on the option D. Shreya was telling for question number 6, and Deep was telling C, and again according to Pausley's equation you are telling option C. Okay, no, but here the answer is for the question number, for a laminar flow through a long pipe, the pressure drop per unit length, the pressure drop per unit length is option D, in inverse proportional to the square of the cross sectional area. Remember please. So always remember here the difference was only a square, remember please. So a square of the cross sectional area. So here you can see the formula. This is the formula, and the d square, and d square is nothing but your area. When you will write in terms of your the velocity, this should be here something comma like that, then you can write this velocity. Okay, no, this is wrong. Here should be little bit comma, yes. Then your delta p is cross sectional to area square. So these three are different. V is equal to, you can write discharge by, what is written actually here not very clearly explained. V is equal to your discharge by area. So discharge by pi by 4 d square. So this should be separate. Once you will not separate, then maybe student get confused. And this is separate and this is separate. So here you can say this is d square, so definitely it is square root of, inversely proportional to a square of, it's not a square root, a square of cross sectional area. Now we'll move on the next question, question number 7. Question 7. The aging of pipe implies which of the following? Aging of pipe: decrease in the value of friction factor, increase in absolute roughness linearly with time and hence friction factor. Option C, pipe becoming smoother with time, all of this. Options, question number 7. So please, it's a general question, very easy question. So please just try to explain. Try to write your answer in the chat box. Deep is telling B and Ghost is also telling B. Okay, means increase in absolute roughness linearly with time and hence friction factor. Yes, so definitely this is correct. Aging means the older, get older and older pipe. So not, this was the very general question. Okay, so now we'll move on the next one, question number 8. For pipe flow, which equation is used to determine the measure head loss? Darcy's Weisbach, Euler, Bernoulli, Mannings. Question number 8. Anyone please? Very easy question. Okay, so you are telling A option. Deep is telling A option. Okay, so Shreya is also telling A. Let me just, very easy question as we have discussed a lot today about this only. The friction factor, the Darcy's Weisbach and all. So the similar one. We use this formula. HF is equal to FLV square by 2ZD. And here F is your friction factor. So actually in the loss is your two type. One is major and another is minor. So major generally due to the your friction or roughness of the pipe. Roughness of the pipe, and minor due to joint, your bend, elbow and all etc. The your like the convergence, divergence also, sudden opening, sudden closing also. So remember, you always remember these formula. Please, I'll recommend you, please go through the all minor formulas. So sometimes the question come from your numerical questions come from this the formulas also. 1 mark question in the gate or you're in the final NPTEL exam. Okay, now question number 9. Question 9. Okay. So in a pi flow, the ratio U star divided by V, where V is average velocity, is related to friction factor F as. So here U star is nothing but your shear velocity. Question not explained. So just I'm giving you a hint. Your U star here is shear velocity. Now you just try to calculate. Try to think what should be the correct one. In question number formula, the yes, so that's why I'm telling here what is why this is coming, what's happening. Hmm, oh, it's what's happened. Yeah. Now, okay, so here you are telling the formula was different. Not different. If your F, let us suppose this is your F dash and F dash. Now your F is friction coefficient, then your formula will be 4FL V square by 2GD. So this is the difference. If this is a friction coefficient, in the previous question was your Darcy's friction coefficient. So that's why 4FL by V square. You can say this is Darcy's friction. When you will consider the friction factor, then FLV square by 2GD. Always remember. So here you can, your friction factor is nothing but is equal to 4 times of F. F dash is equal to 4 times of. Sometimes in the question you will see uh, your friction factor and the friction coefficient, it depend on the how you are writing the equation. If you are writing equation in terms of friction factor, so sometimes people use directly F, but defined F. This is friction factor as I was defined previously. But now I have differently here written F dash here in terms of when you are using the friction coefficient, the F is equal to 4FL V square by 2CD. So hope you got it. So now the next question was here. So next question was in pi flow, the ratio of U star by V, U star is your shear velocity, is related to the friction factor F as. So it is related to like this. Your U star by V is related with this relation have F by 8. How? Your F is equal to, here you can see, your F is equal to 8 tau naught rho V square, and your tau naught is equal to, your tau naught is equal to, you can relate here, or U star you can say, your tau naught is equal to V square rho U star square. So once you will put here 8 rho U star square divided by rho V square. So that will be cancelled out. So 8 U square by V square. So this is the formula of tau. So sometimes we will see your U star is equal to root under tau naught by rho also. So this terminology you need to remember. So it is related with your F by 8 friction factor. Again, if someone told you this is not a friction factor, At the friction factor, someone want to write the friction coefficient. So 4 friction coefficient, if I write with the FC, 4 FC by 8. So this will be cancelled out. So root FC by 2. So here I am using again and again the different sign combination for the friction coefficient. No worry, because it's depend on how we are defining the whatever you are using the variables, how you are defining. Whether the friction factor you can say this FF, also you can write F dash. It's depend how you are thinking and how you are writing. Okay, so now we'll move on the next question, question number 10. Question 10 is, for a fully developed laminar flow through a circular pipe with Reynolds number Re, the friction factor is proportional to Re, proportional to square of Re. Re here is Reynolds number, independent of Re, inversely proportional to Re. So which option will be correct, please? Okay, so hope you got it. So now we'll move on the, okay, already I have explained. So please just try to write your answer in the chat box for question number 10. For question number 10, please just try to write your answer. Yes, Fe is equal to 64 by Re. Option D you are telling, inversely proportional to Re. Okay, fine. Deep is telling option D. Other student, please also, I am waiting. After this question, I will take 5-minute break. So you can also take, no issue. Okay, Bala is also telling D option. Nice. Everyone, please just try to write your answer, because already I have discussed earlier also. What is the relation between your friction factor when I was discussing second question or maybe the third question. So two student is telling option D. Other please. Others. Okay, Shreya is also telling D. Okay, so here option D is correct. Yes, your F is direct inversely proportional to Re in case of laminar. But someone if told you, you have to calculate the F for turbulent, then what will happen? For turbulent, you need to calculate with the Moody chart, Moody diagram, or one formula is there, 1 by, basically Moody's diagram is based on this formula only, 1 by root F is equal to something like that. This formula is, the relation is applicable only for laminar, not for turbulent. Okay, so now we'll move on the next one. Question number, the your new assignments. Okay, so I'm going for 5-minute break. So if anyone want, you can also take. Otherwise, you just try to read first question and try to solve. So now let us solve first question of the second year assignment. So the first question is, which among the following does not depend on friction factor? The pipe diameter, fluid density, viscosity, weight. So now you can just try to write your answer in the chat box for question number first. If you will see here, all question is rounding around your measure head loss, friction factor, your velocities, that is a maximum and minimum velocity. So these are the common question. So always keep in mind when you are going for the examination. So once the question will come from these topics, so you can expect the question from your friction factor and your how your velocity distribution. One question is very important. Let me just explain you. Always remember this relation. Your the relation of u is equal to u max. This relation is very important. R square by capital R square. So this was your pipe flow, laminar pipe flow, and your velocity distribution is parabolic. So at any point, let us here, this is your R and this is your capital R. This is your capital R. And at this location, your velocity is U. And this is your velocity maximum. So this is the relation. This equation is very important. Okay, so now come again on this question. So which of the following does not depend on the friction factor? Here again, your friction factor question is talking about. So the question is not talking about whether for laminar or whether for turbulent, but we need to think the pipe diameter, fluid density, viscosity and weight. So definitely here weight will be your final answer, because your friction depend on viscosity. As we just, if you will imagine, then you can also image, able to image in your mind. Now fluid density definitely, and the pipe diameter, yes, of course. Now the detailed solution, the friction factor F depend on velocity of flow, fluid density, pipe diameter and viscosity of pipe. Roughness of the pipe is also important criteria to determine the friction factor. Yes, that is good. Now we'll move on the next one. Question number 2. So question 2 is, the total head loss for the system is equal to pipe length, pipe diameter, width of the reservoir and height difference of reservoirs. The total head loss for the system is equal to, you have, let us suppose the system of reservoirs, so with the diameter and length of the pipe and reservoir. So now here you need to think about how we will calculate the total head loss, whether it is equal to height difference of the reservoir, width of the reservoir, pipe diameter, pipe length, which one? Total head loss. Very tricky question. So if you will think, you will get. Okay. So Bala was telling for the previous one D. Yes, of course D was correct. Shreya was also telling, and Deep was also telling that D1. Okay, fine. Now again, the Bala is telling for question number 2 is D, height difference of reservoir. Okay, I'm expecting the answer from other students also. So please just try to write your answer from for question number 2. Which option may be correct? Okay, Gauss is also telling D. Nice. Other student, please. Okay, height difference of reservoir. Nice. Okay, so you all telling the option D. Yes, D is correct here. So if you go for calculating the total head, your D will be correct. Detail what is written here. Total head loss for a system is equal to height difference of reservoirs. Height difference is denoted by letter H. Okay. So total head loss can be equated by summing it up with all local losses and the losses at each pipe. Okay, it's when we'll talk about the series and parallel. Okay, now we'll move on the next one. Which of the following is measure loss? Friction loss, shock loss, entry loss, exit loss. So, okay, so Bala is telling A option for question number 3. Other student, please also. Actually, I need answer from all participants because uh, I have explained in the first one when I was discussing the 2025 assignment. Which of the following is a measure loss? Shock, entry, exit, friction. Okay. Gauss is also telling A option. Friction loss. Okay, you all telling option A is correct. Nice. As we have discussed also the previously, in the pipe there are two type of loss. One is major, one is your major, another is your minor. So in the major loss, your friction, and in the minor, all these three and others also. So here option A is correct for question number 3. Okay, so we'll move on the next one. Okay, so here answer is visible. For a laminar flow in pipe, the momentum correction factor is, remember, for laminar flow in pipe, the momentum correction factor is 1.33. Remember, momentum correction factor for laminar and turbulent. So for laminar it is 1.33. For turbulent you need to explore what will be the value. Now another factor is also there. This is represented by beta. Another is alpha. The your I think kinetic energy friction factor, something like that. So well, it's depend on the velocity distribution. So remember please. So for laminar and for turbulent also you need to calculate. Just go through kinetic energy correction factor, I think. Okay. So what is your momentum correction? The momentum correction factor is defined as the ratio of momentum of flow per second based on actual velocity to momentum of flow per second based on average velocity. Means your momentum based on actual velocity divided by momentum based on average velocity. So this is the ratio of your momentum correction factor. I think alpha is a kinetic energy correction factor. Okay. Okay, so here it is given. For turbulent flow, the momentum correction factor is slightly higher than 1. So it is 1.12, and for laminar its value is 1.3. So beta for turbulent is greater, beta for laminar is greater than beta for turbulent. Okay, so now we'll move on the next one. The question number 5. Which property of fluid accounts for the major loss in pipes? Density, specific gravity, viscosity, compressibility. Which property of the fluid account for major loss in pipe? So I need answer from your side for question number 5. Everyone please just try to write an answer. Okay, so C, Deep is telling viscosity and Bala is telling C, means you both are telling viscosity. Okay. Other student, please also you just try to write your answer. Whatever you are thinking, whatever in your mind, you just write here. Which property of fluid accounts for major loss in pipes? Okay, Shreya is telling C also. You all telling C. So here, which property of fluid accounts for the major loss in pipe? So definitely your viscosity is correct here. So the major loss for the flow through a pipe is due to the frictional resistance between adjacent fluid layers sliding over each other. And this resistance arises due to the presence of viscous property of the fluid. Hope you understand. Now, okay. So question number 6. In the flow rate of water in a pipeline is double than the pressure drop will be original value. So here you need to fill in the blanks, same as 2 times 4 times half. If the flow rate of water in a pipeline is doubled, then the pressure drop will be same as original value. And two times of original value, four times of original value, one half of original value. Flow rate means here you need to think about how your pressure related with the flow rate. If you know, then you just double the discharge and look how pressure changes. For question number 6, please just try to write your answer here. Little bit more analytical thinking, so we'll think, definitely we'll get the answer. Such type of question always you please try to approach your based on the formulas whatever you know, not just for your general understanding. This here general understanding will not help you. Your formula, definitely the fundamental formulas will help you here for such type of questions. Okay, so Ghost is telling C option. Okay, other student please also try to write your answer. Okay, Shreya was also telling C. Okay, fine. That is the four times of the original value. Okay. 1 minute also I'll wait, then I'll explain you. Okay, so let me just explain it. So here you have the flow rate. This question, this one we have already discussed this equation as in Pauli equation in the previous one. Okay, so no issue. So now your del P is equal to, here the formula is written very clearly. Rho z will be cancelled out. So your del P is equal to 32 mu UL by Z d square. Now you can write this in terms of U is equal to, or discharge is equal to area into velocity. So velocity is equal to discharge by area. So you can write here. Once you will write, let me go a little bit lower. So once you will write here, delta P is equal to 32 mu Q L by AD square, means here, so delta P is directly proportional to Q. So now if it is directly proportional to, so what will happen? You have the relation directly proportional to. So now just think, your initially flow rate was Q1. Now finally your Q2 is Q1 two times, Q1 into 2. So here it is written. So your delta P1, delta P2, Q1, Q2 by Q1 means, let me just write you. So delta P1 is directly proportional to Q1 and delta P2 is directly proportional to Q2. Here I think some mistake is there. Here some mistake is there, I think. It should be, because if it is directly proportional to, so it is delta P1 by Q1, delta P2 similarly your Q1 by Q2. Delta P1 is like that, delta P2. Now Q1 and Q2 is 2Q1. So it will be cancelled out. So your pressure delta P2 you need to calculate. Your P2 will be delta P1 by 2. That is one half of the, how it is 2 times here it is written. If it is directly proportional to, then you can write like that. So anyone want to give the comment here? For turbulent flow is 4 times what you are telling, FLV square by 2GD. So you are telling about head loss. Question is asking about the, okay. So question is asking about the pressure. Remember, pressure drop. So if you will go with this formula, you can come up with this D option, one half of the, not 2 times, because it's directly proportional to here. If you will see here, some I think calculation error. So okay, so anybody want to say something? Okay, so I think here some this is the calculation mistake, so you can think on that. Or you can think like that also. Here your pressure is directly proportional to velocity. If suppose that for a particular pipe area is constant. Remember, area is constant. Means if you are increasing Q, so whatever you will increase, your velocity will increase because you are not going to increase the area. So area is constant. So your when you will increase the Q, let us suppose area is 2 meter square. So you are increasing velocity. So as you will increase velocity, then your the difference of pressure here, P1 by P2, should be increased. So here I think bit confusion is there. No, the solution is not like that because this is your P1. The here is the difference. Question is asking about the pressure drop. So your initially was P1, then you have some discharge Q1, then you come up with P2 and your discharge is Q2. Now your pressure difference is directly proportional to this. So if the question was about the pressure difference, then you can go with this such type of solutions. But here is question asking about the pressure drop, means from P1 to P2. So if you will put here the P1 and P2, like we can write the P1 minus P2 is equal to Q1, and again P1 minus P2 is equal to 2Q1. This is your first case, this is your second case. Then how you will solve? Okay, anyway, just try to think on that which option will be correct. So we'll move further. According to this, whatever here is explained in the question, so the answer will be here, you can see very clearly, but here is not correct. This is not correct as per the this explanation. So just think on that. So we'll move on the next one. Question number 7. Okay, so hope everyone got the issue. What is happening here? Here the solution is whatever is explaining. It's not based on the formula written here. Okay. So now we'll move on the question number 7. Question number 7 is a liquid flow through a pipe 1 and 2 with the same flow velocity. If the ratio of their pipe diameter D1 is to D2 be 3 is to 2, what will be the ratio of head loss in two pipes? A option 3 is to 2, B option 9 is to 4, C option 2 is to 3, D option 4 is to 9. So please just try to write your answer in the chat box. Okay. So everyone please, or in between, let me just search what will be the correct one. Everyone please, or let me just show you the answer. Question 1. Okay, so now you can solve. So here we can see what should be the correct one. Okay, so here it is showing 2 times the square root, how it is. Okay, so if I go here in the textbook, so it's 2 time. How? Cancel. Okay, we are doing the same thing, but why? In the solution it is written, yes. Here was the mistake. Just the final step. Here, please. You can see. Hope it is visible. So here is in the final. Uh, Here is the mistake. Once you will get this one, so what your delta P2 is like that, delta P2 will be 2 times of delta P1. So means 2 times, not half. So here was the in the final one I did mistake. So you always remember, please be very careful. So you can just see with the silly mistake, I was getting the different result. So option B is correct here for question number 6. Okay, so now hope you got it. But here is mistake. This was the completely mistake. So delta P1, delta P2 is equal to Q1 by Q2. So once you will put here Q1 divided by 2Q1. So Q1 will cancel out and delta P2 will be 2 delta P1. So hope you got it. Okay. So now please just think for question number 7. Question number 7, please. Okay, Bala is telling C option, that is 2:3. So hope previous question number 6 you all got it. If yes, please you can just write yes. So that will be good for me. Question number 7. For question number 7, you are telling C, that is good. Other student, please also try to write your answer in the chat box. So always remember, please, some small mistake may change your entire analysis in wrong direction. So always remember. Deep, anyone? Deep? Okay. I was thinking you are want to tell something. Okay. So I'll wait 1 minute more. So remember, a liquid flow through a pipe 1 and 2 with the same flow velocity. If the ratio of their pipe diameter d1 and d2, then what will be the ratio of head loss of two pipes? So here diameter difference is there, and the liquid flow through a pipe 1 and 2 with the same flow velocities. If the velocity is same, and okay, okay, you all telling C. Let me just go through. So here you know one formula for the head loss. What is F is equal to HF. Here you need to consider the material properties is same. If the material property is same, then F will be the constant. So from both sides that will be the cancel out. Both side means what I'm trying to explain here. Flow through a pipe this. So here you need the diameter ratio you have. So head loss ratio. Ratio means HF1 by HF2. And this is HF is equal to what? FL V square by 2GD. Now here you have the difference of D only. Means your HF is inversely proportional to D. Means HF1, this is your D2 and this is your D1. Velocity is same, so velocity cancel out, length should be also same, then you can cancel out. Anyway 2 and G is constant. So here your D2 is 2 and D1 is 3. So 2 is to 3 will be the correct one for question number 7. Okay, so one thing remember please, here your mat for this question material of pipe is same and length also similar, say same distance same length. Okay, now question number 8. The water flow through a circular tube with a velocity 4 meter per second. The diameter of the pipe is 15 centimeter. Take kinetic viscosity of water 10 raised to minus 6 meter square per second and density of water 1000 kg per meter cube. So here you need to calculate what? Okay. Water flow through a circular. So here what do you need to calculate? I think Reynolds number. Diameter of the pipe is there. Take kinematic viscosity and density. Yes, you need to calculate here the Reynolds number. In the question is not mentioned, so please just try to calculate the Reynolds number here. Yes, 1 by d1. Okay, okay. Sorry for the mistake here. This is 1 by d1, not hf is equal to 1 by d1. 1 by d, yes. So that's why here I have written d2 by d1. Yes, here was the mistake, slight mistake. Okay, thank you. So now we'll move on. Please just try to write answer for question number 8. Reynolds number. Very easy. You need to calculate, but
So another I'll give you 1 minute. So within 1 minute, please just try to calculate. Okay, Shreya is telling C, that is 10 raised to 8. Deep is telling 10 raised to 5. D option. Okay. Ghost is telling C. Okay. Okay. Bala is telling D. So maybe slight mistake. Remember here the diameter of the pipe is given in centimeter. So you need to consider these things also. And here diameter is given or density is given. The kinematic viscosity is given, not dynamic viscosity. Okay, so deep is telling 10 raised to 6 minus 6. Okay. Oh no, no, you are telling 4 is to 0.15 divided by 10 raised to minus 6. Yes. Okay, so now let me just show you the answer. Yes, here D is correct. But how? Let me just explain you. RE is equal to rho V, diameter of the pipe, divided by dynamic viscosity. And what is dynamic viscosity? When we will relate with the kinematic viscosity, how the kinematic viscosity relate with the dynamic one. So this is your kinematic viscosity. So dynamic viscosity divided by rho means you can write rho here by replacing from numerator. So RE is equal to VD by dynamic viscosity. So it is nothing but V is 4 into D is what? 0.15 meter, and your this is also in meter, 10 raised to minus 6. So 15 here is 100, 15 4 just 60. Okay, 60 divided by 10 raised to minus 4. So it will go in the numerator. So 6 into 10 raised to 5. So this will be your correct one. So option D is correct here. So if anyone getting other options, you please just check your calculation part where you are doing mistake. Okay, so here option A, question is, when a problem is stated, the velocity of water flow in a pipe is 20 meter per second. Which of the following velocity is it talking about? Average velocity, RMS velocity, absolute velocity, or another one, uh, instantaneous velocity? Let me, I'll give you the answer. Instantaneous, or local velocity also you can say. So which will be the correct? Whether option A, B, C, D? For question number 9. Very easy one. like the previous question, given the velocity is 4 centimeter per second. So this velocity, whatever here you are using, this is what? Whether this is RMS, average, and what? If this is your RMS, then answer will be the RMS. If this is will be average, then your velocity answer will be average. If this is absolute, your answer will be absolute. If this is instantaneous, answer will be instantaneous. So definitely, this is your average velocity. Remember, please. Always remember, this is your average. Okay, Bala as was telling option B. Option B is correct for this question. Average velocity. Or in the option D was the relative velocity. So, okay, no issue. Now question number 10. Here you have, which among the following formula for friction factor for circular pipes? 16 by RE, 64 by RE, RE by 16, RE is equal to, no, RE by 64. Friction factor, not friction coefficient. So this is equal to what? Your 64 by RE or 16 by RE. Okay, I'll give you a hint. Maybe these, anyone correct from option A and B, out of A and B. Any option. Anyone, please. Okay, 64 by RE. For 10 and all your Bala is also telling D. That is good. So yes. So here option B is correct. 64 by RE. 64 by RE. If it was the friction coefficient, then 64 by RE, then it is FC is equal to 16 by RE. So one thing here you can remember, if FF is greater than FC, then in case of friction factor for laminar, that will be greater. So using this just the simple understanding, you can remember whether it will be the 64 or 16. If this is a small, then in nominator is small. If this is greater, that will be greater. So you need to always remember this relation. Okay. So now we'll move on the next one. Question number 11. So hydraulic mean depth. Hydraulic mean depth for depth of circular pipe of diameter 100 when running full. Hydraulic mean depth here you need to calculate. When running full. So what will be the correct one? Very interesting question. Hydraulic mean depth. Anyone please? Try to write your answer. Okay, no issue. Okay, for 11 you are telling B option 25. Okay, so here hydraulic mean depth is equal to area by weighted perimeter. So area is already you know pi by 4 d square. Perimeter is pi d, so d by 4 means 100 by 4 you will get this one. If question was asking about the hydraulic mean diameter, then what we will do? Diameter. Then the formula for hydraulic mean diameter HD is equal to 4AC. Remember please. 4AC by P means 4 pi by 4 into d square divided by pi d. So pi will be cancelled out, dd will cancel out. So hydraulic diameter HD, Hydraulic diameter is nothing but your diameter of the pipe. But when you will go through the rectangular channel, then hydraulic diameter will be the different. Remember. Now we'll move on the last question. Okay, so this was we have already explained also. So in turbulent flow in a pipe of friction factor given 0.045, estimate the ratio of shear velocity to mean velocity. So shear velocity mean velocity ratio already we have discussed in the previous one. So once you will calculate, you will get 0.075. So option C is correct here. Now we'll discuss very quick your next one. So major loss in turbulent flow pipe varies. In turbulent flow, question is asking approximately square of the velocity. Remember please. In turbulent flow, question is asking about. Okay, approximately, not exactly. Now hydraulic mean depth of the circular pipe of the diameter already we have explained is d by 4. Now we'll move on the next one. The discharge in laminar flow through pipe varies. Discharge with the inverse. Yes, we have already discussed how your discharge and pressure related. This is directly how it is, whether it is viscosity. Yes, it is viscosity, inversely proportional to viscosity. We have already discussed the pressure directly proportional to your discharge, but here the question is viscosity, so it is inversely proportional to viscosity. Remember. Next one, laminar flow through a pipe, Reynolds number less than greater than laminar flow. Remember please, it's sometimes always remember Reynolds number greater than or equal to 2000 for the velocity distribution for steady laminar flow in a pipe is steady laminar. Already I have discussed uh, in the first question of today's discussion, the parabolic. Okay, so now the ratio of maximum velocity average velocity in the pipe. This question is very important. So always remember please, your this value will be the 2, means your u max is equal to 2 times of average. This is very standard. If flow in between the plate, then your u max is equal to 1.5 times of the u average. So this is for circular pipe, this is for in between the plate. Now we'll move on the next question, number 7. So what radius from the center of the pipe of radius r the average velocity occur? So this is very important. Always remember r is equal to r by root 2. Very important. So how you will calculate this relationship? So this relationship also you need to remember with these topics. Okay, the maximum velocity in circular pipe when the flow is laminar occur at bottom, center and where? So you know already it will be that center. Now the shear stress distribution in the pipe given by, so it is option A, tau is equal to minus delta P by delta X R by 2. Very easy. This is also we have discussed lot today, so no need to explain here. Option A is correct. In case of laminar flow, the loss of pressure head is proportional to, already we have discussed, velocity, or you can say the discharge flow rate. Okay, in laminar flow is characterized by, so in the layer, parallel layer, fluid flow in the parallel layer, always remember. Okay, so now end. So hope you enjoy today's session. So we have discussed a lot today about the questions, around 34 questions. So thank you for your attention. So we'll meet again on 22. Okay, so thank you. Thank you, Bala. Now you can leave the class, no issue.